polar coordinates. What's the ordered, an ordered pair might look like this. And what does that mean? What does that 3 stand for? How far away from the pole you are. So out 3 units from the pole. And what does the pi over 6 stand for? The angle. The angle, so here's pi over 6. 1, 2, here's 3, so that's where that point would be. And we discussed if there are other ways you can name that point. It doesn't have to be 3 comma pi over 6. It could be lots of other things. Remember that conversation? Yeah, okay. Go back and remember that conversation. What we're going to do today is we're going to convert polar back to rectangular because I have plotted that point polarly, but if I put that on a piece of regular graph paper, it would also have coordinates, right? And I want to know what would those coordinates be. So, very, very simple. In a polar system, we have an R and we have a theta, right? That's what we have. In a rectangular system, we have an X and a Y. So that picture ties together both the rectangular coordinates and the polar coordinates. So could you build any equations from that picture? Any equations, use your imagination. What is something I could say? An equation I could write, Charlie?
X squared plus y squared equals r.
Absolutely. Absolutely, that's true. So again, what Charlie just do? He built an equation that has some rectangular and some polar in it. Right? Can you find any more? Can you think of any other equations?
4 cosine theta equals x.
What'd you say?
4 cosine
4?
theta is x.
Where's the 4?
Or r
R.
cosine.
So Leo says, since cosine theta equals x over r, x equals r cosine theta. Right? Cosine theta equals adjacent over hypotenuse. So he went ahead and got rid of the fraction and said x equals r cosine. Well, similarly, then what? Y equals r sine. Right, now wait a second. We need to take, I'm on example 4, we need to take the ordered pair 2 comma pi, which is r and theta, and we need to change that into an x and a y. This is example 4, we already finished. Right, now you guys have everything you need. This is easy. We're trying to find x. What do we know about x? It's r times cosine. Well, wait, we know r and theta. So x will be 2 cosine pi. What's cosine pi? -1. So 2 times -1, x is just -2. And then y is 2 sine pi. What's the sine of pi? 0. So there we go. Now I want you to think about that for a second. Doesn't that make perfectly good sense? Where is the polar point 2 comma pi? Isn't it right here? Isn't that 2 comma pi? Where is that on a rectangular system? -2, 0. Yep, yep. Okay, go ahead, on your own, do B and C. It is exactly the same thing. They give you an R and a theta. So this is R and theta, and you are finding X and Y. Remember, X will be 4 cosine theta, and Y will be 4 sine theta.
When you did that negative, you just
So do we know that it's R and theta?
Yes, because it says convert to polar coordinates.
Wait, sorry. It's gonna be positive. It's negative, yeah, negative
Times 4. So then
5 equals negative 4,
negative 2 root 3. Like negative 2 root 3.
and then you put it as, oh, and then there's negative 2.
Okay.
So positive. The y that is 4 times negative 2.
This is what I got for B. This is what you got for B? Look okay? And again, let's try to make it make sense in our brain. Where is 5 pi over 3? Where is that angle? Which quadrant? 5 pi over 3? Quadrant 4. So in quadrant 4, what do I know about X and Y? X is positive and Y is negative, right? Okay, did you get to this one? This is what I got for this one. Okay? Now, which quadrant is that point in? The first. But wait a minute, my angle is in the third. But what? A negative R. What does a negative R do? Remember, we talked about that before break. A negative R moves you 180 degrees. It moves you to the opposite side of the circle. So this is in quadrant 3. But the negative R is gonna push it to quadrant 1, and that's why your X and Y will both positive, because that point is actually in quadrant 1. All right, feeling okay about that? Easy. All right, now what about the other way around? Now we've got rectangular coordinates, so this is X and Y, and we're gonna change it to R and theta, polar, all right? So this is rectangular. We want R and theta. So remember your picture that we had up here a minute ago? Oops, not like that. X is -2, Y is 2. Here's R. Remember what Charlie told us? Can we find R? Absolutely. So what's R? 2 root 2. Square root of 8. 2 root 2 for R. Now, that isn't theta. This is actually theta right here. Theta has to be in standard position. So that's theta. But this angle right here, I think you can tell me what it is. What is that angle? That guy right there.
45.
What?
Pi over 4.
Pi over 4. Why is that pi over 4, you guys? Because x and y match. And doesn't that only happen at pi over 4? Now, if that angle is pi over 4, vacation's over. Engage. If that angle is pi over 4, then what is theta? 3 pi over 4. How did we get that? This is pi, right? So wouldn't that be pi minus pi over 4? In other words, it's the second quadrant pi over 4 angle on your unit circle, 3 pi over 4. All right, how about 1 negative root 3? What's R?
2.
2? Everybody okay with that? R is 2? Now, this is theta, okay? This big angle is theta. I need to find this one first. Charlie, we did the Pythagorean theorem, which is what
I'm
you
so
told
sorry.
us to do. Caitlin?
11 pi over 6.
Okay, wait a second. Tell me where this is coming from.
From the negative root 3 over 2.
Okay, so let's be careful. So you said, I mean, I don't know who's right, but you said, okay, if I think of this as a unit circle,
Yeah.
then this point would be 1/2 negative root 3 over 2. I don't think that's a pi over 6, though, is it?
Oh, no, I meant to switch it. It would be root 3 over 2, comma, negative 1/2.
Okay, but that's not what point I have here.
Yeah.
So I have this point.
Yeah.
I can't change that. So what angle is that? What kind of angle is that?
Pi over 3.
Pi over 3. But it's the one in quadrant 4, so it would be
5 pi over
5 pi over 3. Good job. Good job. All right, try the last one on your own. Oh, it's kind of easy. But go ahead, try the last one, see if you can get it figured out. What's your R?
5.
5. Your R is 5. That's your distance from the pole. That's 5. What's your theta? This is an easy one. Theta is 3 pi over 2. Very, very good. We're going to get a little more practice with that, but we're going to just shift our, the way we look at it, just a little bit. Anybody have a question so far about one of the numbers we came up with on any of those problems? Okay, now I'm going to look at example 6. And it says the complex number is represented by a point in the complex plane. I can't remember if we did this back in unit 1 or not, but let's talk about it for a second. So the complex number is represented by a point in a complex plane. The point is -2, -8. So -2, -2 right here, that point right there represents a complex number. Now, these are rectangular coordinates. A complex number, but give me an example of a complex number. What's a complex number?
2i.
So that would be pure imaginary, but yeah, like 5 plus 2i. So this, that's x, that's y, that's -2 minus 2i. Because a complex number is x plus yi. That's a complex number. So since I have been told that x is -2 and y is -2, my complex number is -2 minus 2i. And when I plot a complex number, I plot it exactly as it says, as an ordered pair. Okay? Now, this is point -2, -2. So if I make my little triangle here, this is -2, this is -2. What's my r? 2√2. What's my theta? Five pi over 4. So my r is 2√2, and my theta is 5 pi over 4. All right, now this is just one of those little technicalities. If you had the ordered pair -2, -2, back in example 5, you would rewrite that ordered pair as this polar pair, right? Everybody's got that r and that theta. Example 6 says, okay, but this isn't really an ordered pair, it's really a complex number. So remembering that x is our cosine theta and y is our sine theta, you know that, remembering that, then a complex number, x plus yi, could be written as r cosine theta, that's x, plus r sine theta, I. Complex number, x plus yi, in rectangular form. When I change that to polar form, then instead of x, I have r cosine, and instead of y, I have r sine. So this is the polar form, sometimes called the trigonometric form of a complex number. The r and the theta, the x and the y, when it was an ordered pair or when it was a number, the x and the y are the same. When it's an ordered pair or a number, the x and y will be the same. So your complex number in polar form would be 2√2 cosine 5 pi over 4 plus, normally we move the I to the front, so I sine, I 2√2 sine 5 pi over 4. If you put the I at the end, make sure you have this in parentheses. All right, so the point I want to make is, it looks different, but it's the same math. The math is the same. This ordered pair corresponds to this ordered pair. This complex number corresponds to this complex number. Okay, so let's look at example 7. is the same thing, only backwards. Example 7, we are starting with the polar form. You don't really need all those parentheses, but I'll put them in. So that is a complex number. That's one of these. We want to change it to its rectangular form. Isn't this just x? So what's the cosine of 7 pi over 6? Cosine 7 pi over 6. We shouldn't have to think this long. Negatively 3 over 2, perfect. So when I simplify that, I'm going to get negative 2 root 3. What's the sine of 7 pi over 6? Negative 1/2. So minus 2i. So this was the trigonometric form, r and theta. This is the rectangular form, x and y.
You have to put the 2 in parentheses or no?
What?
You have to put the 2 in parentheses.
No. Okay? All right. Let's do one quick thing here. Go to page 4. Let's do these 5 problems real quick and then we'll do some review. All right, so here we are on page 4. All right, number 1, plot the point on the grid. Okay, you can do that. So pi over 3 is labeled, go out 3 circles, 1, 2, 3, you got it, right? All right, give 2 other coordinates for the same point. So 3 pi over 3, you have already plotted that. What are 2 other names we could give that very same point? There are lots, let's just come up with 2. Well, you can go with negative 3, but then what happens to that angle? If you make that r negative, your angle is going to change by pi. So 4 pi over 3. Yes, that would be one option. That would be one option. What's another option? If I want to leave the 3 positive, then I have to change my angle by 2 pi. So if I add 2 pi, what is that, 7 pi over 3? I could also subtract 2 pi, whatever you want. Perfect. Anybody have a question about that? All right, next point is negative 5, 7 pi over 4. Well, I'm going to fix that right now. I do not like negative r's. Where's 7 pi over 4? Down here in quadrant 4, right? So if I change the sign, then I'm going to have to move my angle over here. What will that angle be? 3 pi over 4. And that's where I'm going to plot my point. 3 pi over 4 is your angle out 5 circles. What's another name for that? 5 comma, what'd you say? 11 pi over 4, that would be one. Don't forget you can also subtract 2 pi. So we could do negative 5 pi over 4, that would be another one. If you leave r positive, then you just change your angle by 2 pies. If you wanna change the sign on R, make it negative or positive, then you have to change your angle by 1 pi. Okay. If the point R, theta 1, and negative R, theta 2, have the same location on the polar grid, what can you conclude about the angles? They're pi apart. They're pi apart, guys, right? All right, convert 4 comma 2 pi over 3 to rectangular. All right, so this is polar, I want rectangular. All right, who remembers, we did this a little bit ago. X equals, bingo, X equals 4 cosine 2 pi over 3. Y equals 4 sine 2 pi over 3. Gotta know that unit circle, huh? Absolutely. So cosine 2 pi over 3 is negative 1/2, very good, so that's negative 2. And the sine is positive root 3 over 2. So that'll be 2 root 3. Go the other way. 1 comma root 3 is rectangular, and we want to change it into polar. So I love what Caitlin did earlier. She said, okay, here's my situation. X is 1, Y is root 3. What's R? Yeah, that's 2. But then Caitlin said, I need to figure out that angle. So I'm going to put this in a unit circle by dividing everything by 2. So the ordered pair would be 1/2 root 3 over 2, which I should recognize as what angle? What angle is that? Under 3. Which point is further from the origin? The point with rectangular coordinates, negative 5, 3, or the point with polar coordinates, 6 comma 5 pi over 6. How far from the origin is 6 comma 5 pi over 6? 6. R is the distance from the origin. So that one is 6 units away. Actually, I don't think they are. Because negative 5, 3, this would be its distance from the origin. And what is that? Root 34. So the polar point is actually further away, because it's 6 away, and this one's only root 34 away. Okay? All right. Let's pause there. What is that? 3:13. That will be due on Thursday. All right? So 3:13 is due on Thursday. By the way, I don't know if any of you noticed, but for 2 weeks, I've had a chapter 7 test on your calendar. Wrong class, that belonged on somebody else's calendar. So sorry about that. We are gonna be having a quiz. It will not be over chapter 7, because we don't even have a chapter 7. And I can't believe no one asked me about it.
We were gonna.
like that weird.
I don't know.
Like I can cross it out in my calendar.
Yeah, well, we all.
All right. So, here is what we're gonna do. We do not have a ton of time to devote to this. This is all stuff we already know how to do, but it's been a while. That's why I want to spend some time reviewing it. So, today, I am going to do a few particular ones that I have chosen, and then tomorrow, I'm gonna rely on you. We're gonna do a little bit of lesson tomorrow, a little bit more of the polar stuff, and then we'll review some more. But we will review what you have spent some time practicing here and say, oh man, I don't remember this. Got it? The ones I wanna do, I wanna start with number, I don't know, my numbering system is crazy, 2H. So it's like almost with the end. I was doing this in the car and I was being distracted and we're gonna do 2H, which is, you are going to prove this statement is true. Yes, I know. Someday you will be, yeah, and then after J, I put another H because obviously someday you'll be old and this will have a new T. All right, here's the problem we're doing. Find it. This is what we're doing. Your job is to prove that this, use some stuff to it, ultimately will end up with this, okay? That's what we're doing. So I want you to look at this right here, and as a mathematician, we're gonna use our identities. Our identities are gonna be involved, not in step one, but they're gonna be involved. As a mathematician, what occurs to you when you look at this right here? That's a fraction. That's a fraction. I'm subtracting that. What has to happen? I gotta have a common denominator. So my common denominator will be 1 minus and 1 plus. So the first fraction needs a 1 plus, and the second fraction needs a 1 minus. Right? I'm getting a common denominator. So I'm simply making my denominators match. Now, they match, right? So I'm gonna make one fraction, and this is the denominator, my common denominator. Now, what's my numerator then? Well, this part would be 1 plus cosine. And then there was a minus in there. So this part, distribute, so this will be minus cosine plus cosine squared. Is that right? Right, okay. So what does that leave me with on the top? 1 plus cosine squared. And if I FOIL the bottom, what will that leave me with if I FOIL the bottom? 1 minus cosine squared. Now this is where your knowledge of the identities is critical. What is 1 minus cosine squared? 1 minus cosine squared. is sine squared. Guys, I'm not gonna write this down again. We know that sine squared plus cosine squared is 1. If I subtract that cosine squared, doesn't it say that 1 minus cosine squared is sine squared? Yeah. So now I've got 1 plus cosine squared over sine squared. Now, this is where I'm headed. This is what I'm trying to end up with. Anybody see a way to make that happen? Real easy. Charlie?
Make it one over sine squared x. Would that be times? Yeah, time.
No,
Or
plus.
sorry, plus. Oh.
Cosine
plus,
squared
okay.
over sine squared. So in other words, uncommon denominator it. Pull it apart, so it's 2 separate pieces, because your answer is supposed to be 2 separate pieces. Well, what's 1 over sine? What's the reciprocal of the sine? Cosecant squared. And what's cosine over sine? Cosine over sine is cotangent. Yeah. So there you get it. Now, there's one more of those. The very next problem. The very next problem is very similar. Let's work our way through it. All right, here we go. Everybody should be writing right now because it's very similar to the one we just did. At least it's going to start the same way. What do we got? Fractions being subtracted. Gotta have a common denominator. And the common denominator will be 1 plus 1 minus. So the first one needs a 1 minus. The second one needs a 1 plus. So my common denominator is 1 plus sign, 1 minus sign. That's my common denominator. Everybody with me? So what's my numerator? Well, isn't that going to be a FOIL? So 1 minus 2 sine plus sine squared. If I FOIL this guy right here, now don't I have to FOIL this one too? So minus, I gotta put parentheses there because I'm subtracting that whole thing. So where do I get when I FOIL that? 1 plus 2 sine plus sine squared. All right, tell me what you notice. I've gone through and done my,
The denominator is
what's the bottom?
cosine squared.
Cosine squared, cosine squared on the bottom. What happens on the top? The ones are gone. Sine squareds are gone. I have negative 4 sine x.
How'd you remove the 1 plus sine squared, or sine x? Oh wait, no, you just turned it into.
I foiled that,
Nice, okay.
right? That's a foil. Leo,
Should you break up the cosine squared x into two?
in cosine, cosine. So Leo says I have -4 times 1 over cosine times sine over cosine. Now, before you start getting confused, just stop a minute. Is this the same as this? And because that's what I needed to end up with more pieces, I had to split this up into pieces. What's 1 over cosine? Secant. And what's sine over cosine? And there you go. You've got it. Okay? I also want to do the very first problem. So keep track of which ones I've done, and you're gonna go home tonight and spend some time looking at this review and practicing on your own. But let's get problem number 1. You need a calculator. Problem number 1. We're solving.
Yeah.
All right, here we go, fans. What do you think? How do we start? Factor it. Love it. We're gonna factor it. And when I factor it, how is it going to factor? Have to be a 2 secant and 1 secant. Would you agree with that?
Yes.
You're gonna have to have a plus and a minus, not sure where.
-3 plus 5.
-3 plus 5, I heard from someone. Yeah, who shared that idea? Very good, Celeste, you are, I think, correct. How can I check to see if she's correct? Foil it, distribute it, yeah, looks good. So what does this say? This says that the secant is 3/2, or the secant is -5. Would you agree with that? Now, I don't do secants, and my calculator doesn't really do secants. So, if the secant is 3/2, that means the cosine is 2/3. And the cosine is -1/5. Because the cosine is the reciprocal of the secant, right? Okay. I need a calculator because nowhere on my unit circle is there a 2/3. There's a √3 over 2, but not a 2/3. So, where would the cosine, where could the cosine be a positive number? Certainly in quadrant 1. Where else? 4, perfect. Now I'm gonna go to my calculator, and I'm gonna find this angle right here. How am I gonna find that angle? What am I gonna type in? Second cosine, 2/3. And I'm I'm gonna get 0.841. So I have a 0.841 in quadrant 1, which would be 0.841. That's the quadrant 1, 0.841 angle. Now, how do I find the quadrant 4, 0.841? What? 2 pi minus. Very, very good. Very good, Parker. So minus 2 pi, or 2 pi minus, and I got in quadrant 4, 5.442. Remember, all the way around is 2 pi. This blue angle is all the way around except for 0.841. So that's why he said take 2 pi minus 0.841. Okay? Now, where is the cosine negative? Well, it would be either here or here, right? Now, I need you to be really careful with this one. My suggestion is that we find this angle right here. And to find that angle, we don't use the negative. We just do second cosine 1/5. Because, let me write down my answer here. The reason I do that is because I am looking for the angle with a 1/5 cosine in quadrant 2. So I'm gonna find the angle with a 1/5 cosine, and it's 1.369. But that is not the answer. The answer is the quadrant 2 version of that, and how would I find it? Wait. How am I gonna find this? It doesn't have anything to do with pi over 2. Pi minus, yeah. So it's pi minus that number. So that angle, this angle right here, is 1.772. All the way to my hand is pi. I stopped 1.369 before I got there. Now, I need the third quadrant version of 1.369. So how am I gonna find the third quadrant version of that angle? Pi plus, yep. And I got 4.511. All right, one more. 2D. Name all the vertical asymptotes of 4 secant 3x minus something. It doesn't matter. That doesn't have anything to do with the vertical asymptotes. Remember, what does that number do? Whatever, I don't even know what it is, I made that up, but whatever that number is, what does it do? Shifts your picture down or up, whichever way, and that has nothing to do with the asymptote, so it really doesn't even matter what that is. What does matter is that you remember what a secant looks like. A secant is the reciprocal of the cosine. So I dashed in my cosine, and then I have dropped in the asymptotes, and then you know you flip the curve. Now I know we haven't done this for a long time. You gotta remember it. Secant is reciprocal of cosine. So you should definitely have memorized your cosine curve. You drop in the asymptotes wherever the cosine is 0. So where are the normal asymptotes for a secant? Aren't they at pi over 2 and then pi later and pi after that and pi after that? So pi over 2 plus pi k, where k is an integer. So in other words, start at pi over 2 and then every pi you have an asymptote. All right, that's the normal. Right here is the normal. What does that number do?
Does it, oh, it divides by 3.
Divides by 3. So instead of this being at pi over 2, it's going to be at pi over 6. Because this is getting divided by 3. So this is pi over 6, and this isn't pi. This is pi over 3k. And that is where all of your asymptotes are for that. All right, so boys and girls, you have 2 things. You got a 313 homework due Thursday, and then for tomorrow, you are going to pick out some problems to do after we do our COLA stuff tomorrow. Got it? Please look at this review sheet. We are not going to have time to do every problem. So it will be up to you to do some practice.